Hey guys, welcome to my channel XRD. Today we will discuss about solid state chemistry and what is crystal. So let's begin. So first of all, we will learn about state of matter. Matter can be divided into four groups: solid state, liquid state, gaseous state, and plasma. Solid state can be divided into two groups: crystalline solid and amorphous solid. So we will mainly focus in the crystalline solid. Crystalline solid can be divided into five groups: atomic solid, molecular solid, ionic solid, covalent solid, and metallic solid. Now let's see the shapes of solid. This is a cube. All sides are equal length. I have an example. This is a Rubik's cube. This is the typical example of a cube. These all lengths are equal. Now the next one is a square-based prism. This is a square which is the base of the structure, and this is a prism. The next one is a cylinder. This is a cone. This is called a cuboid. This is a triangular prism. Triangular, and this is the shape of prism. This is a sphere, and this is triangular based pyramid. This base is triangular in shape. So these are 8 types which I have shown here. Now, what is crystal? A piece of solid substance which is homogeneous and has regular geometrical form is called crystal. The main important thing is this word homogeneous. Oh, yeah, this word homogeneous and the regular geometrical form. So whether a piece of substance is a crystal or not, we can identify it by XRD. XRD means X-ray diffraction. This is a technique which can say whether the substance is crystal or not. We will come in XRD later. Now see, crystal lattice. The symmetrical three-dimensional array of atoms or ions inside a crystal. Mainly the physicist prefers to say atoms and the chemist prefers to say ions. There is no problem, you can say any one of these two. Now this is a representation of crystal lattice. Just consider all the atoms or group of atoms as a point and then draw the whole crystal. This will be a crystal lattice. What is unit cell? Unit cell is the smallest group of atoms which has the overall symmetry. This is very much important. Overall symmetry of the crystal, and from which the entire lattice can be built up by the translation in 3 dimensions. So this is the definition of unit cell. The two most important things are, this one is overall symmetry and another one is this: the entire lattice can be built up by the translation. Now unit cells can be of two types: primitive and non-primitive. What are the primitive? Only the corners of the unit cell contain atoms or ions. So in that unit cells where only the corners are occupied by ions, those are called primitive unit cell. And what are the non-primitive unit cells? Atoms are placed at the corners as well as at the center in the case of body-centered of the unit cell, or at the center of any face in case of the face-centered. So we will discuss later in detail. In case of body-centered, here inside inside it there is an atom, and in case of face center, all these face centers have an atom. Okay, though I don't know how to solve this Rubik's cube, but I will demonstrate all this with the help of this Rubik's cube. Okay, now come to the next point, XRD. XRD stands for X-ray diffraction. It is a rapid analytical technique primarily used for phase identification of a crystalline material and can provide information of unit cell dimension. The XRD analysis is based on constructive interference of monochromatic X-rays and a crystalline sample. So, let's see, X-ray diffractometers consist of three basic elements. One is X-ray tube, rare X-ray tube. Second is a sample holder. This is a sample holder. And another one, X-ray detector, this detector. X-rays are generated in a cathode ray tube by heating a filament to produce electrons, filtered to produce monochromatic radiation, collimated to concentrate, and directed toward the sample. Now, one of the important things is, why do crystals diffract X-rays? So just try to understand. Crystals are regular array of atoms, and X-rays are basically electromagnetic radiation. The wavelength is almost of the same order, and the order is 1 to 100 angstrom of magnitude as the spacing between planes in the crystal. So basically the plane of the crystal has the same order of magnitude with the wavelength of X-ray. Another one question can appear that why not other electromagnetic waves can interact with crystal? Because the other electromagnetic waves has longer wavelength which cannot match with the spacing inside the crystal. And if we think about the gamma ray has lesser wavelength. Still, we do not use gamma ray as it has higher energy, which can form some defect in the crystal. Even gamma ray can be considered as a pair of positron and electron. So if we just set up gamma ray if we put gamma ray in the crystal sample, so this can make some defect inside the crystal. So for this we just use X-ray in the XRD machine. Now I told you that there are three parts in the XRD machine. Two of these three main parts will rotate. So only two will rotate within these three. For many machines, the source is static and the sample and detector rotates. But for others, the sample is fixed and the other two rotates. In this case, we have taken the sample as fixed and the other two, X-ray tube and the X-ray detector, rotates along this line. And this is the omega angle and this is the 2 theta. Basically, omega equals to theta. And this setup is called Bragg-Brentano setup. So this is it for this video. In the next video, we will learn about Bragg's law. Thank you.